This video will show you how to construct a linear equation from the context of a word problem. We will be able to identify a pattern and then use that pattern to interpolate or extrapolate extra data that is not directly given to us. So let's take a look at our example problem. Apolline is mowing lawns for a summer job. For every mowing job, she charges an initial fee of $7, plus a constant fee for each hour of work. Her fee for a 5-hour job, for instance, is $42, and her fee for a 3-hour job is $28. We are asked to let Y represent her fee in dollars for a single job that took X number of hours for her to complete. So Y is her fee, and X represents the number of hours she worked. And then we are asked 3 questions. First, construct an equation for the relationship between the fee and the number of hours worked. Second, once we have our equation, how many hours would she have worked if she had made $63? And how much money would she make for 6 hours of work at a single job? So first of all, we know, because this talks about her charging a constant fee for each hour of work, we know that this is going to be a linear relationship. So we're dealing with a straight line graph here. And we know that we can use the equation form y equals mx plus b. So let's take a look at the first question. Construct an equation for the relationship between the fee and the number of hours worked. So we're going to take a look at the steps that are needed in order to construct an equation. And remember, we are using that y equals mx plus b form, where m represents the slope of a line and b represents the y-intercept, or where the line crosses over the y-axis. Okay, so basically, we need to find our slope, we need to find our y-intercept, and then we can plug those numbers into this form of an equation, and we'll have a complete equation. So before we can start looking for those pieces of information, we need to create a table of values. So we know from our problem that Y represents her fee in dollars, and X represents the number of hours that took her to complete a job. So we can create our table, X representing the hours worked, and Y representing her fee in dollars. Okay, so we have the basis for our table, and now we need to see if there's any information in our problem that we can add into that table. So we know that her fee for a 3-hour job is $28. So we can say 3 hours, $28 for a fee. Okay, that's our first point that we can put into our table of values. We also know that for a 5-hour job, her fee is $42. So 5 hours, $42. And there we have 2 points already that we can start with. And that's all that we need right now. We know already that this is a linear function. So we don't need a lot more points to be able to see if there's a pattern. We're already told right from the get-go that this is linear. So we can assume that whatever pattern exists between these points will continue. Okay, so now that we have our first 2 points, we can start to look for these values of slope and y-intercept. Okay, so my next step is going to be to find the slope. And there's 2 ways that you can do this. One would be to graph this information onto a Cartesian plane. These essentially are 2 ordered pairs. We can say 3, 28, so 3 on the x-axis and up 28 on the y. And we have 5 and 42. And once we have those 2 points, then we can find the slope using rise over run. So that's the first way we can look at to find slope. Graph the coordinates and then use rise over run in order to find the slope. So I have here my graph. I've got on my x-axis the hours worked, And you'll see that I'm going, just to make it a bit more clear, 2 blocks is equal to 1 hour for my scale. And then on this side, on the y-axis, I have the fee that is charged in dollars. And again, for scale, just for saving space, each block is worth $2, and I've gone up in increments of $10. So I've graphed these 2 points, 3 hours, $28 fee. So at 3 hours, I'm up here at 28. Here's 20, 22, 24, 26, 28. So 3 and 28. And then I have 5, and I go all the way up to 42. So here's 40, and up by 2s, so it's 42. Okay, so there is my line. Now, if I want to find the slope, I need to look at the difference in those points. I need to see what is the rise versus the run. So here I'm looking at how much do I rise on my y-axis, and then how much do I run on my x-axis. So remember, on my y-axis, I'm counting by 2s for my scale. So I start here and I go 2, 4, 6, 8, 10, 12, 14. So I'm rising 14. And then from there, I'm going to run. And remember, my scale is a little bit different on my x-axis. For every 2 blocks, it's really just 1 hour. So I've got 1 hour, 2 hours. Okay, so I'm running 2 from 3 to 5. Okay, so there's my rise and my run. So I can put those values in, rise of 14, run of 2, and that reduces to 7 for my slope. So my slope here is 7, and that is her hourly rate. If we're looking at that, that is her fee charged per hours worked. So how much you charge per the number of hours you worked is your hourly rate. So the other way we can find that, if you don't want to stop and draw a graph, which is a bit time consuming, is we can just take a look at our table of values here. And we can use delta y over delta x, or the change in the y value as compared to the change in the x value. So if we look at my table of values, to go from 28 to 42, I am increasing by 14. So my change in y is 14. And to go from 3 to 5 on my x column, I am rising by 2. Okay? So 14 over 2. So a change of 14 and a change of 2. And that, of course, also equals out to 7. Okay, so you can see that those are 2 ways to find slope, but it's really, you're doing the same thing. Rise and run. Rise is just another way of saying how much the y value is changing, and run is just another way of saying how much the x value is changing. So it's good to, when you're first learning, to get used to putting it on a graph, because it gives you some practice in the skills of graphing and taking information off of a graph using rise and run and things like that. But if you're kind of used to it, you know what you're doing, this way saves you a little bit of time so that you don't have to draw the graph every time. So we have our slope, 7. So we're going to put that into our equation. Y equals, instead of m, we're going to put 7. And everything else stays the same. So we still need to find our y-intercept. And once we have our y-intercept, then we'll have a complete equation with just our 2 variables, x and y. So step 3 is to find the y-intercept. I have 3 different ways that I can do this for this particular problem. The first way is to use logic. So we know the y-intercept is anywhere where x equals 0. Because when you look at a graph, the y-intercept, wherever a line crosses this y-axis, any point on this y-axis, the x-coordinate is 0. Okay, so any y-intercept is always going to have an x-coordinate of 0. So what they're basically asking me is, when x is 0, what is y? What is her fee in dollars when she has worked x number of hours. Okay. What is the fee when she has worked 0 hours? And we can just take a look at our question. You might think if she's worked 0 hours, her fee is 0, but that's actually not true. We know that she charges an initial fee of $7. Okay, so before she even begins working, just to get out to the job site, she charges $7. And then on top of that, she charges a set fee for each hour of work. So what is her fee when she has worked 0 hours? It's $7. We know that just from reading the question. So our y-intercept is 7. However, for all questions, you might not be able to use logic just to find what the y-intercept would be. So I'll show you a couple of other ways. The next way is graphing. So I can use my graph and I can find where this line is going to cross the y-axis. Now this line, as it is, doesn't cross the y-axis, but we know it's a linear relationship. So we know that this line is going to continue at the same slope until it crosses this y-axis. So what I can do, I know my slope. We have a rise of 14 and a run of 2. So I can continue that pattern just in the opposite direction. So I will run 2 to the left, and then I will drop down 14 to continue my line. So I'll go 2, 1, 2, because remember each, on my x-axis, 2 blocks is the same as 1 hour. So we have 1 hour, 2 hours. So there's my run, and then I'm down 14. And remember, each block is worth 2 here. So 2, 4, 6, 8, 10, 12, 14. So there's another point. Okay, so we know if she worked 1 hour, she would charge $10, $12, $14. Okay, and then I can go again, and I can say 1, 2 hours, and I can go down 2, 4, 6, 8, 10, 12, 14 would be here. Okay, so now I'm going to use my ruler. It's important that you use a straight edge for this, especially if it's not going to fall right on the line, and this one won't. Okay, so I use my straight edge, I extend my line, and now I can see approximately where it crosses the y-axis. It's not right on the line, it's actually in between these lines. So if I zoom in here, you can see it doesn't cross right on these lines. So this would be 8, this would be 7. It actually crosses right in between. So we can kind of estimate it's likely 7.5 is where it crosses. Okay, but I'm not super confident with that. I'm like, well, maybe I didn't draw my lines really straight. I'm kind of estimating there. So I'm going to show you a third way that you can find the y-intercept, and it's a lot more reliable. Okay. Oh, sorry. Actually, when you look at this, I forgot about this. So because this is 8, this is actually 6. So halfway in between would be 7, not 7.5. My mistake. So that is pretty accurate, but it's still hard to tell. Is it exactly halfway through, or is it 3/4 of the way between 6 and 8? It's a little bit hard to say. Okay, so on this graph, because it's unclear, we're going to try another method. So method 2 is to graph it. Method 3 is to use our equation. Okay, so we have y equals mx plus b. We already know that our slope is 7. Okay, so we can put that in. We also know a couple of points on this line. So we know 3, 28, and we know 5, 42. So what we could do is actually take one of those points, our x and y, and we can substitute that into our equation and then solve for b. So let's use that point 3, 28. So if I put in 3 for my x value and 28 for my y value. Let's see what we get. So instead of x, I'm going to put in 3 plus b. Now I only have one variable. So I can actually rearrange this equation and isolate my variable b to find out what it would be. Okay, so let's work out this 7 times 3. So 28 equals 21 plus b. So I've got a 21 added to b. So in order to get rid of that 21, I have to subtract 21. And I have to subtract 21 from my other side as well. 28 minus 21 is 7. So I'm left with b equals 7. So I got the same answer as what I got when I used logic. I got the same answer as what I got when I graphed it. Although with the graphing, it was a little hard to tell if it was exactly 7 or if maybe it was like 7.5 or 7 3/4. It was a little hard to tell. This way we know because we've used math to calculate it. Okay, so my y-intercept is 7. So now I can go back to my equation and I can substitute in for my value of b, 7. And now my equation is complete. So that's the last step, is to substitute in your slope and your y-intercept, and you end up with your complete equation. Okay, so that's the first question that it asked us. But this is a 3-part problem. So part 1 is done. Construct an equation for the relationship between the fee and the number of hours worked. Well, we know it is y equals 7x plus 7. Okay, so her fee can be calculated by taking the number of hours she works, multiplying that by 7, because she charges $7 an hour, and then adding another $7, which is her initial fee. Okay, so that's how you get that equation. Now that we have an equation, we can tackle these other 2 questions. So how many hours would she have worked if she made $63? Okay, and there's a couple of ways that, again, you can tackle this. You could go to your graph and you could be like, okay, at 63, so here's 60, 62, so it would be at this point on my graph, if I continue this line up, I can draw this line. I know it's going to continue in a straight line, but it's always a little tricky. So we can continue this line straight up, and we're saying at 63, so we want to know, that's where it is, 63, what is the x value? So you can kind of go down, and it's a little hard to tell for sure, somewhere between 7 and 8 hours it seems. Okay, but again, with this graph, with the scale that I've used, it's a little bit hard to tell for sure. With a better scale, we would be able to see it a little bit better. Okay, but we know it's, somewhere in between 7 and 8 hours it seems. So there's other ways you can do this. How many hours would she have worked if she made $63? I can take my equation that I found, y equals 7x plus 7, and I want to know how many hours, so I'm looking for x, if she made $63, which is the fee. So I can substitute y equals 63 into my equation, and I can solve for x. So if I have $63, I want to solve for x. Now I just have one variable, and I can isolate it. So the first thing I want to do is get rid of this plus 7 by subtracting 7 from both sides. That would give me 56 on the left side and 7x on the right side. Now I want to get rid of this multiply by 7, and I multiply, to get rid of a multiply by 7, I divide by 7 because we do the inverse operation. So I do that to both sides. 56 divided by 7 is 8. So we know that she works 8 hours if she makes $63. Okay, now when we did that on the graph, see how it wasn't exactly correct. It wasn't totally accurate. It's off by a little bit. And that's just because of either the ruler or the scale that I have here. So that's why a graph, sometimes you can estimate it, but you can't always get an exact answer. But doing it this way, you can get an actual exact answer. So substitute your fee into the equation, and then you can solve for your number of hours, which is your x variable. Okay, so we go back to our question. How many hours would she have had to work? 8 hours. Okay, and the last question is very similar. It says, how much money would she make for 6 hours of work at a single job? So again, I can look at my graph if I want, and I can say at 6 hours, if I go up to my graph, it's right here, I can say, looks like she would make $50. Okay, that's what it looks like on my graph. So I can confirm this, though, again, using math to calculate it. So again, I'll start with my equation that I found. Okay, and I want to know how much money is she going to make. So what I'm looking for is my y value, the money or the fee. If she works 6 hours. So we're saying when x, or the number of hours, equals 6, what is the y value? So we can substitute this 6 into my equation. Y equals 7. Instead of an x, we're going to write a 6, and then plus 7. And then we just calculate. Y equals 7 times 6 is 42. And 42 plus 7 is 49. So you can see our graph was close. It looked like it was about 50, but it was not exact because of the scale being what it was. But we know when we use math, we can actually find a definite answer. So our answer for this one is $49. Okay, and you could also do that by just kind of continuing your table of values. Oh, there's my son. Just a second. Hi, guitar. Hi. That's the guitar. Go on. Sorry about that. Dangers of teaching at home. So another way that you could do this, as I was saying, is to put or to take your table of values and just extend it. Okay, so if you're looking for this pattern, we're going up by 2's every time. You could keep going up. We could say for 6 hours. Now that's only going up by 1 this time. So instead of going up by 14 here, if you're continuing the pattern, you would have to cut it in half. And you'd say I'm only going up by 7. Okay, so then 42 plus 7 gives you to your 49 again. So that's another way that you can also use that pattern to continue your table of values and find the data that you're looking for. And you can do that the same for looking for the question we did for how many hours would she work if she made $63. We could continue this to find out where 63 lies and then see what the matching number of hours would be. So a lot of different ways to approach these problems, but I hope this gave you a bit of an overview and an example of some of those methods that you could use. Okay, so thanks for listening, guys, and I hope this helped you a little bit. Bye.